You type a message, you hit send. 2 seconds later, it's in someone's inbox across the world. Feels instant, but what actually happened in those 2 seconds? Your email did not travel directly from your laptop to theirs. It went through multiple servers. It was packaged, encoded, authenticated, routed through DNS, checked for spam, verified cryptographically, then stored on another machine, waiting to be retrieved. Let's walk through the entire invisible journey. No fluff, just how it really works. Step 1. The email isn't just text. The moment you click send, your message gets structured into a very specific format. An email has 2 major parts. 1. Headers. This is the technical metadata. From, to, subject, date, message ID, a globally unique identifier, return path, routing information added later by servers. Headers are critical. They tell servers how to handle the message. 2. Body. The actual content. Plain text, HTML, embedded images. If you attach a file, it can't be sent as raw binary data. Email systems were originally built for text only, so attachments are converted using something called MIME, Multi-Purpose Internet Mail Extensions. MIME encodes files into base 64 text so they can safely travel through text-based systems. On the receiving side, they're decoded back into their original form. So before your message leaves your device, it's already been packaged into a standardized format that email servers understand. Step 2. Your email client talks to an SMTP server. Now the sending begins. Email uses a protocol called Simple Mail Transfer Protocol, SMTP. SMTP has existed since 1982, and yes, it's still the backbone of email today. Your email app connects to your provider's outgoing mail server using TCP, usually on port 587, modern standard with encryption, port 465, implicit TLS, port 25, mostly server-to-server today. Before anything is sent, encryption is negotiated using TLS. This protects your credentials and message while in transit. Then comes the SMTP conversation. It looks like this under the hood. EHLO, identify the client. Auth, authenticate. Mail from. RCPT2, data. It's basically a structured back and forth. Your client says, I'm sending from this address. I'm sending to this address. Here is the message. When the server replies with 250 OK, it means message accepted for delivery. Important detail. Accepted does not mean delivered. It means the server has taken responsibility for it. Step 3. Authentication and anti-abuse checks. Before your provider lets the message move forward, it verifies you're allowed to send it. This happens through SMTP AUTH over an encrypted TLS connection. Without authentication, anyone could use a mail server to blast spam. That used to be common in the early internet. It's why modern servers are strict. Step 4. Finding the recipient's mail server, DNS and MX records. Now your email provider needs to figure out where to send the message. Let's say you're sending to someone@example.com. Your server performs a DNS lookup for that domain. Specifically, it looks for MX records, mail exchange records. MX records tell the internet which servers are responsible for receiving mail for that domain. DNS responds with something like, mail.example.com is handled by mail.example.com. Now your server knows where to connect. Step 5. Server-to-server delivery, store and forward. Your server opens another SMTP connection, this time to the recipient's mail server. They perform the same SMTP handshake, EHLO, mail from, RCPT2, data. This is called store and forward. Each mail server that accepts the message temporarily stores it and takes responsibility for forwarding it to the next destination. If the receiving server is temporarily unavailable, your server doesn't give up immediately. It queues the email and retries delivery for hours, sometimes days, before declaring failure. That's why email is resilient. It's designed to tolerate downtime. Step 6. Security verification on the receiving side. Now the receiving server doesn't just trust your email, it runs multiple checks. SPF, Sender Policy Framework, checks whether the sending server is authorized to send mail for that domain. DKIM verifies the digital signature added earlier. If the content was modified in transit, the signature fails. DMARC defines what should happen if SPF or DKIM fail. Reject it, quarantine it, accept but flag it. Then comes spam filters. Modern spam systems analyze sender reputation, IP address history, content patterns, links, attachment types, machine learning models trained on billions of emails. If your email looks suspicious, it goes to spam. If it violates policy, it can be rejected entirely and bounced back. Only after passing these checks does the receiving server accept it. After accepted, the message is handed to a mail delivery agent. It's stored on disk in the recipient's mailbox database. At this point, SMTP's job is done. The email is sitting on the recipient's provider's server, but the recipient hasn't seen it yet. Step 8. Retrieval, IMAP or POP3. When the recipient opens their email app, a different protocol is used. SMTP only sends mail. Retrieval uses IMAP, Internet Message Access Protocol, keeps emails on the server and syncs across devices. POP3, Post Office Protocol 3, downloads mail to one device, often removing it from the server. Most modern systems use IMAP because it allows syncing across phone, laptop, tablet, everywhere. When the recipient opens the message, MIME attachments are decoded, HTML is rendered, tracking pixels may load, and read receipts may trigger if enabled. Only then does it appear in their inbox. What about encryption? There are two kinds. Transport encryption, TLS, protects the message while traveling between servers. End-to-end encryption, like PGP or SMIM, encrypts the message itself, so only the intended recipient can read it. Most regular emails use transport encryption, not end-to-end encryption, so providers can technically access message contents unless additional encryption is used. What if something fails? If the email can't be delivered, you receive a bounce message called a non-delivery report or NDR. If the mailbox is full, the address doesn't exist, or the domain has no valid MX record, delivery fails. Servers retry delivery for a defined period before giving up. How long does all this take? Usually 2 to 5 seconds, sometimes faster, sometimes longer if there's queuing or graylisting involved. But in that tiny window, DNS lookups happen, 2 SMTP conversations occur, authentication checks run, cryptographic signatures are verified, spam systems analyze the content, the message is written to disk on another machine, all in seconds. Why email still works after 40 years? Email is decentralized, open standard, store and forward resilient, backward compatible, extensible. No single company owns it. Gmail works with Outlook. Outlook works with Yahoo. Private servers work with all of them. It's one of the most interoperable systems ever built. Messy, yes. Old, definitely. Still incredibly reliable? Absolutely. The next time you click send, remember, your message didn't teleport. It went through one of the most battle-tested communication systems ever engineered. And it did all of that before you even switched tabs. Have you ever had an email bounce or end up in spam? What happened? Drop your email horror stories in the comments. And if this deep dive into email delivery blew your mind, hit that like button and subscribe for more explanations of the tech we use every day without thinking about it.